Let's take a look at this example. In this example, we're supposed to find the current IS. Please notice that voltage source is given and the Zener Diode voltage is given, so we can find very easy current IS. IS is equal voltage source minus VZ over RS. Okay, so this is equal VS 20 volts minus 5.1 volt over RS 300 ohms. This is equal 20 minus 5.1 is equal divided by 300. This is equal 49.67 milliamps. Okay, so this is my current IS. Next, I'm supposed to find RLmax. RLmax is equal IS minus IZK. Okay, so I'm using KCL. This is my IS, this is my IZ, and this is my IL. I'm supposed to simply realize that if I'm going to subtract from IS the minimum current of my Zener diode, I'm going to obtain the maximum IL. That's why I'm using this formula. So if IS is equal 49.67 milliamps minus 1.4 milliamps. So I have IL max is equal 48.27 milliamps. Okay. Next, I'm supposed to find the resistance RL minimum. Okay, RL minimum is simply the voltage VRL divided by IL max. Okay, so this is the formula where VRL is equal to VZ. Why? Because these two components are in parallel. That's why I'm going to write over here 5.1 volts divided by 48.27 milliamps. Okay, so this is equal 5.1 divided by 48.27 exponent 3 negative is equal 105.65 ohms. Okay, and now I can say that the problem is solved.